Okay, so in this video, we are going to look at integration. So today we will be doing an introduction to integration. So this is all of the stuff that you would have learned in AS level maths that you need as a foundation for A level. So if you're going on to A levels, you need to know this in order to start. So we'll start with what is integration. Then we're going to look at the basic rule of integration. Then we'll do indefinite versus definite integral and the absolute values and integration, and why we need to often find the absolute value in integration. So let's start with integration. So what is it? Well, if you start with calculus, they always begin with your differentiation. So differentiation, you should know, is finding the slope of a graph. So if I have a function, and let's call this function f of x, it's a yellow function here. Then if I was to find the slope of the graph, I would find f dash of x. Okay. So that's not integration. That is the opposite of integration. Integration, instead of finding the slope, is finding the area. Okay, so if I was to find the area under a graph, this area here, I would be wanting to find the integral. Okay, so the area. So integral is the way of finding an area, right? The area under a graph. Okay, and these functions can come in a number of different forms. You know, they're not necessarily here, like f of x is f of x equals x. In other words, f of x could be y, right? The reason they say f of x is because if you have multiple graphs, so you have another one, say, coming like this would be g of x. And so when we started with maths, we said y equals x, but now the y just is called g of x or f of x, but that's what it means. So this would be y equals negative x. So the integral is the way of finding the area under this graph. And so let's look at some notation. So if I wanted to find the integral, the terminology I use is I will look at this s thing here, and you'll say f of x. Okay, and this terminology says that if I want to find the area under this graph, I need to find the integral of the function. And so I would then substitute in a value of x if I wanted to find the area. But we'll go on to that in the rule of differentiation, integration. Okay, so what is integration? It is a way of finding the area under a graph. And it is the opposite of the differentiation, which is finding the slope of a graph. Okay, so now that we've done that, let's look at the basic rule of integration. So there's a number of different, more complicated rules, but the main one we're going to deal with is the power rule. And that says that if you have a function, let's say f of x, and you want to find the integral of f of x, you'll take each value that has a power. So let's say your f of x is equal to, say, x squared plus 2x plus 1. What you'll do is you need to add 1 to the exponent. So let's say that I have something like x to the n. Right. Actually, we'll make it k, because there can always be a number in front of the thing. So let's say that so this is the rule part, which is often more complicated. So it's often easier to see it actually in practice. But if I was to look at the rule part, I would take the k down. And what I would do is put the x there, and then I would add 1 to that n, and then divide by that n plus 1. So whatever I've added to the exponent. So this is what it would look like. So if I said, find the integral of k x to the n, this is the power rule, I would do this. Now, let's look at it in practice. Okay. So, if this is f of x, if this is if I want to find the integral of f of x, I would say x, and what do I do to that 2? I add 1 to it, so it becomes 3, but then I divide by 3. So look at how that's changed. I've added 1 to the 2, and I've divided by 3. The next one, look at 2. 2 is the k, right? 2 just comes down. The x, I add 1 to that x, so it's x to the 1 because the default, it's a ghost 1 here. It's there, but you can't see it, is I put 2 there. I'd add 1 to that x to the 1, and then I put a divide by 2. Then what I do is the 1, anything without an x, if you think about it, that you could think of it as being x to the 0, right? Because x to the 0 is 1. So if you think of, basically there's no x, what I do is I just pop an x on. Okay, so it actually just becomes plus x. And now what I always have to do is add a c. Okay, now the reason is, if I was to find the derivative of 1, that would be 0. But the reason there's a c, it's a bit complicated, but basically just know that the derivative of 1 and the derivative of 2 and the derivative of 3 is just 0, 0, and 0, right? Because there's no x. So how do I know what that was? I don't know what the 3, the 2, or the 1 was if I just have 0. So because I don't know what it was, I have to just put in a c, which means it could have been any of these. So c just means any number that doesn't have an x on. Okay. It's not super important that you understand that now, but just know that you need to put a c on. Okay, so that's the basic rule of integration. Okay, so let's do a few examples, and in your head, hopefully you will follow along. So 3x to the 2 plus 7x, and let's do one with a negative. X. Let's do an interesting one. Let's do something like square root of x. So for this one, okay, we know we bring the 3 down because that was the k. We add 1 to the 2, and then we divide by that exponent, which was 3, plus, and then 7, bring down the 7. We add 1 to the x, so that becomes x to the 2, and of course we divide by that 2. Okay, and that would be the integral of this, which simplified 3 over 3 is just 1. And so we have x cubed plus 7 over 2 x squared. We can write it like this. Now this one, when we add 1 to minus 2, it becomes minus 1. Divided by the minus 1, because we divide by whatever that was. The half. Okay, we did say a half. And then it's the x, we add 1, so it becomes 2, divided by the 2, plus, and then this we have to think of as x to the half, because the square root of x is x to the half, so when we add that, it becomes 3 over 2 over 3 over 2. Okay, we need to simplify that a little bit. This becomes negative x over to the minus 1, which actually becomes, well, we'll do one more step. A half divided by 2 is a quarter, x squared. And then this becomes 2 over 3 x to the 3 over 2. Remove a picture of me here. Okay, and so when I have x to the minus 1, I don't want a negative exponent, so the x goes to the bottom and becomes plus x to the plus 1. So it just stays like that. Then we have a quarter x squared, and then we have 2 over 3 x to the 3 over 2. Okay, let's look. So that is the rules of integration. That's the basic rule of integration. So now let's look at an example before we do this absolute value. Okay, so let's look at first of all the original function that I drew there, the y equals x, right? The f of x equals x. Okay, so let's say that I wanted to find the area over here from, I know what I've missed. I've missed one of the things. That's why it's not making sense. We need to do indefinite versus definite integral. So we'll come back to that. We'll do definite integral here. Okay, so we'll go back to and we'll draw that function. X equals x. Okay, so the integral of this, so the integral of f of x, in other words, the integral of x. What do? We add 1 to the exponent and we divide. So it's just 2. So we get a half x squared. So this is what we call the indefinite integral. I haven't defined any value. So in other words, I haven't said where I'm getting the area from. Okay. But now let's look at the area under this graph, right? So let's say that we went to 1, right? So this value would be 1, and then y would be 1 as well. So if we were to find this area here, it's the area of a triangle. Well, that's a half base times height, right? So the area here, if we were to do it without the integral, just intuitively, a half base, the base is a unit of 1. And then the height is 1 here. So it's 1, 1. And so we get a half. That would be the area. Well, if I was to sub it in, I would get, oh, by the way, we have a plus c here. So we have a half, 1 squared, which is a half. So we see we get the same value, plus c. Okay, and the reason for this plus c is because we don't necessarily know just from the integral what the original equation was, because there could have been a value that we couldn't define. But that's fine, because for now, let's forget about the c, and let's just, because it just so happens that it works for this one, because we're starting at 0. So here we have another square and then another thing. So if we were to work out this one for the pink, right, all the way to 2, well, the triangle is 2 and 2, so it'll be a half times 2 times 2. Okay, now if we substitute into the integral here, we would get a half, and then if we put in the 2 squared, we get 4, and a half times 4 is a half. I'm sorry, 2. And so we get, for this one, 2, and this one, 2. So you see that it works intuitively, and it also works using the integral. So the integral would work even if it was a complicated function. So let's try another function. So we're going to go all the way back to the beginning. We're going to change the function to a parabola. Okay, now let's look. Now let's say that now let's say that this is y equals negative x squared, right? So that would be we'll make it a +1. So this would be 1 here, and it's a sad face. Now, if we were to find the area here, okay, we know this value here is 1. Well, what we could do is, we don't have triangles, much harder. We couldn't actually do it intuitively very easily, but using the integral, we can. And so we say y equals, what happens? We say negative. We add 1 to the top. So let's just say the integral of y, we'll just do that, is negative x cubed over that 3. And so we say negative a third x. The integral of this is x. Let's see. Okay, well, it just so happens that it works out nicely, because I'm not going to worry, for now, I'm just not going to worry about the c, because you'll see how the c comes in when we look at definite integral. Definite integral. But we're just going to sub it into the indefinite integral, meaning I haven't defined any regions where I'm finding the area. And so if I substitute in a 1 cubed plus 1, I actually end up with negative a third plus 1, which is 2/3. So I can actually get this area that is 2/3. Okay, which I would never be able to do without this method. And so I was going to say unit squared. For all those integrals as well, I should have been saying unit squared when I got it. Okay, doesn't matter. Just remember to say unit squared because it is area. Okay, now what I'm going to do is I'm going to look at what is the definite integral. So what I've done here is I've kind of done a definite integral by putting in 1, but I haven't really, because what I've done is it says 2/3 units, but this just assumes that I'm going from 0 to 1, but I haven't actually said that. So if I wanted to say the definite integral, I would just say, okay, from 0 to 2, and I actually write in this funny S shape, I actually define the definite integral. So in other words, I define the region that I want to find the area of. So let's say that I say 1 here minus 1. What does this mean? It means find the integral, in other words, the area from 1 to minus 1. So what am I essentially doing? I'm going from 1 to minus 1 over here. Okay, so let's do them in different colors so we can keep track. Okay, so from 1 to minus 1. Okay, so what I can do then is I can say, we'll go from 1. So we'll say, we know the integral. Okay, well, let's just say, we'll start from the beginning. So it was that, but we know the integral is this over here. Let me just, we know the integral is this over here, so I'm not going to do it again. Right? This is the integral. But what this says is substitute in, so go from 1 to minus 1 and put in the integral. So if I start at 1, I say a third, and then I put in a 1 here. And let's do the integral in yellow and the substitution in 1. So the 1/3 cubed plus, that's at x right over here, plus c. And I sub in 1. Okay, and I go from there, and then I subtract the integral from minus 1. So again, the same thing. So this is from there to we're going to do the one in pink, the -1. So we'll put in that sub in the integral. -1/3 3 plus. Okay, so look at the difference. So the indefinite integral, I didn't have these defined values. I just simply found the integral over here. When I define the integral, I'm saying what regions am I finding the area? And so this is the other area bit here. So I'm actually finding this full area here. And so what happens is now we can actually see why the C is important when you're doing the definite integral, and because it actually is nice because it gets rid of those C's. Because when I subtract C from C, they go away. Okay, so the C's go away. And so I'm simply, finding the definite integral takes care of my C problem. And so I've already calculated this as 2/3 over here. So I'm not going, but you can put that in your calculator. And for this, you can just put it in your calculator. So it's 2/3 minus. Now this one, you have -1 times -1 times -1, which is -1, times -1/3 becomes positive. So this is positive 1/3 minus 1/3. So minus 1/3 plus 1/3 gives you minus 2/3. So that bit is minus 2/3. Well, what happens is you minus a minus, you end up plussing. So it ends up becoming 2/3 plus 2/3. So it ends up becoming, I'm going to write it again so that we can see graphically what's actually going to happen here. So plus 2/3 gives us the 4/3. Well, let's go back to the function and look at it. Well, okay, there we go. See, this is 2/3. Well, this is a mirror image. So if this is definitely 2/3, must be 2/3, right? And this must be 2/3. Yeah, running out of time. Okay, so this is the definite integral. The definite integral finds the area under a specific, a defined area. So what do? We find the integral of a function using our rule that we saw earlier, and then we simply sub in values. Now let's look at the importance of absolute values in integration. So what happens is, let's look at this. Let's say that we had to find the area from -1 to 1 on this one. Well, what we notice is this is below the graph. So let's say that we try to do this. So we're going to say, using our integral rule, so we say from -1 to 1. By the way, it doesn't really matter because from -1 to 1 is the same from 1, because it's area. From -1 to 1 and from 1 to -1. An area can never be negative. An area is always positive. That's why absolute values are important. So this is first, okay, let's look at what is an absolute value. Well, absolute value is these long things here. So when you see these long lines, these long straight lines, okay, that means whatever the thing is inside, just make it positive. So the absolute value of -1 is 1, but the absolute value of 1 is also 1. So the absolute doesn't care about the sign. That's why it's so important in integration, because area cannot be negative. So you always want your absolute value. So I can kind of just, I could just do this, right? I'm not going to, but if I put the absolute value in, it says, well, I don't care. I could go from 1 to -1 or -1 to 1. It wouldn't matter. So what is the integral of this? Well, if this was, we said y equals x, the integral is we add 1 to the x, so it becomes 2. And then it's over 2. which is a half. So it's a half x squared. So I'm just going to write a half x squared. We've seen how I've been able to do that. Plus c. Okay, now if I go from 1 to minus 1, I would sub in, first of all, the 1 plus c minus 1 plus c. Okay, so the blue bit, the 1, go from there. And then the minus 1. Well, the c's cancel, we know that. And so we get a half times 1, which is a half. And we know that because the base 1 and 1 is a half. The area, that's a half. Minus, and you see we get minus a half. And minus a half is plus a half. So we get a half. Okay, now that's fine. What if I had gone the other way around? So I'm not going to do the whole thing. Let's just say that I went from minus 1 to 1. Well, if I went from the pink bit, right? So we know that the pink bit was minus a half, right? And the blue bit was a half. Let's say I went the other way around. By the way, some notation. For here, if you see a square bracket here, 1 and minus 1, that is basically what I've done here. So if you see this, so find the integral, and then you see the square in your memo, and then 1 and minus 1. What that basically means is sub in 1 and minus 1. And we see we've done that there with the blue over here, and then the pink here. Okay, if I went the other way around, I would go minus a half. I'd end up with minus a half minus a half, which is minus 1. But the area is not minus 1. It is 1. So to save myself from making a mistake, in other words, if I had accidentally put in minus 1 first, I can just solve all my issues by simply putting an absolute value here and then an absolute value here. So regardless of if I get positive or negative, I still end up with a thing. So if I put the, as I said, if I'd swapped it around, if I have the absolute value here, nothing changes except this minus 1 becomes 1. And so I still get my correct answer of an area of 1. So that's why absolute values are so important, because you can go the other way around. So for example, let's say you don't know the function, right? But they just give you the function and then you algebraically work it out. So let's say the function had looked like that and you'd gone from 1 to minus 1. Well, we saw earlier that when we did a parabola, here. Okay, well, let me just actually, so, it was over here. So when we did a parabola here, we got a positive value, which was fine. We got 4/3. But let's say that we had this, where it was over here and here, but we had done the same thing and we've gone from minus 1. We would have ended up with a negative. But if we had simply just used an absolute value, when we get negative 4/3, it just becomes 4/3. So absolute value is a great way of getting around the fact that if you don't know what the function looks like, you're going to work out the area. And don't worry if you get a negative. We're just going to put the answer as positive. Okay, so that's integration. We've got 3 minutes to summarize. I could do it in less. So question 1, what is integration? Integration is finding the area under a curve. The basic rule of integration says that if we have, say, y equals x squared, we add 1 to that 2, so it becomes x cubed, and we just divide by the 3. Okay, so remember there we had our basic rule of integration. As I said, there's lots more, but that's the basic one that you kind of do for AS levels, and then we'll get into a few more complicated rules as well. but that's the main rule, and it's used to explain everything. Then we have indefinite versus definite, right? So indefinite says, I'm not going to define the region that I find the area. I'm just going to find the integral, which is kind of just giving the equation of the integral, but not actually putting in values. The definite integral says, right, what I'm going to do is I'm going to sub in 2 values and find the area under a graph of a specific area that I need. Very, very handy in, say, engineering and stuff, because, you know, or even anything really, you know, if you're doing economics, because say you don't really want the area of the whole thing, you maybe just want this area here. And this you can just then put in your definite integral, and say it was from 2 to 3, and you just find that area there. And then your absolute values, well, that takes care of the fact that your function can lie below the x-axis here. And so you could then find the integral by simply putting the absolute value, and then say it will take the negative area and just turn it into a positive. Okay, so that's basic integration. And if you want to go into a more complicated example, we're doing some exam questions next. So just keep an eye out for that.